Okay, so in this video, after my previous one where I checked my multimeters for current readings, I thought I'll keep on going with the checks, just because here, I bought this Marconi used secondhand not long ago, and I haven't checked all the its features. So yeah, I thought why not to go on and check all the others features of the multimeter. So this multimeter can check current, can measure current, can measure volts, DC volts, AC volts, DC amps, AC plus DC amps, and resistance, basically. Continuity, if resistance is less than 10 ohms, it will beep very loud, by the way. So, having said that, I'm gonna use once again the Brahman as a reference. I'm gonna use the power supply for the DC voltage source. The specs of the Marconi are: you can measure voltages up to 300 volts. This ranges 30, 3 and 300 millivolts. In fact, we are now on the 300 millivolts top scale. With maximum crest factor of 3.1 at full scale. DC or AC up to 1 kilohertz. Input impedance 6 megaohm. Okay. The accuracy will be plus minus 3% of the reading, plus minus 1 millivolt, plus minus 1 digit. So let's start with with 100 millivolts. Okay, here we go. I'm reading 110 here, 0.89. Um, 111.7. So yeah, the difference is about 1%. So I would say it's within the specs, and we can see on the bar chart that we are 1/3 of the scale. Let's move on a little bit, move up a little bit. Let's go to 300. Yeah, 309.86, 311. Yeah, so this is basically 310. So yeah, I would say still within specs. It changed the range to 3 volts because we are more we settle at more than 300. If I will decrease a little bit, let me see, another bit. We go back now. We should go back to the 300. Yeah, we can't get. We can go manually. Oops, too much, too far. Yeah, there we go. Back to the 300 millivolt range, top of the scale, 292.1, 290.66. So yeah, very close. Yeah, on range up, and we go and check I don't know, 1 volt. Yeah, that's 1 volt. Go and change this. So 1005, 101. Yeah. So if we consider 3%, 1.01 times 3%, that's 3% of that number, and plus 1.01. Actually, let me do 1.01 minus 1.01 minus that amount, it will be 0.9797. So we are already within the spec with 3% of tolerance. Let's go up to 2 volts, 3 volts, and we change the range here. Okay, and remembering that we are on the bottom of the scale actually here. 4 volts, 5, 6. I got a change here of the scale. 7, 8, 9, and 10. And let's go to 20. And let's go to 30. Actually, let me go to 29, because otherwise it will change the range. 2905.5, 6, 7. There you go. 29.7, 29.9. Yeah. So we can go higher than this with my power supply. So yeah, I would say the meter and the Marconi is giving good results in terms of DC voltage. Let's go and try some AC voltage and AC plus DC voltage, and after that we'll check some resistors. I have some resistors in here, and I was already checking using this potentiometer. Yep, so let's go ahead. Okay, so we are set up for some AC signal. Looking at the lower part of the window, I think I can change that. I'm pretty sure I can. No. Channel set. No. System. Display mode. Single view. There you go. So there you go. We got a single view now of a 50 Hertz signal, like the main outlet frequency, 10 millivolts RMS into high impedance, like this multimeters. So 10 millivolts. What I'm reading here is 9. Oh, sorry for the lights. 9.95 and 10.3, 10.1 oscillating. Okay, so what is the accuracy of the Bremen on AC voltage? Well, let's have a look. The A69 has got an accuracy of between 20 and 45 Hertz. So actually we can go to this range between 45 and 30 and 300 hertz. On the first range, which is the 500 millivolt range, the accuracy is 0.3 plus 20 digits. So it's pretty accurate. So that will be, if we go and do some calculations, 9.94, which is its reading, times 0.3%, 9.94 plus this, plus 20 digits, so basically the first and second decimals. So let's go plus 0.2. So 10.17, let's call it 10.17. 10.17 minus 9.94. So the window for the error is 0.23 or 230 microvolts, up or down. So for the Marconi instead is still 3%, so plus 1 millivolt plus 1 digit. So this is already on a 10 millivolt measurement. This is already 10%. So what that means, it means that checking this result, Marconi has got a pretty accurate reading. Okay, let's increment now to 100 millivolts in here. 100 millivolts RMS. We could also check for non-sinusoidal signal. We can read the frequency. Yeah, pretty good, pretty good. Let's go to 200 millivolts. And 300 millivolts. Marconi has changed the scale. So let's go a little bit down to go back on the lower scale. That's too much, so let's go to 90. Okay, so 290.4, 291. Yeah, there's also a function here where you can hold the max reading for some reason, if you need that, and reset. Okay, let's go now to, let's move on to 500. After that, we'll have to change here the scale. So yeah, once again, pretty accurate. Let me change the scale now. Let's go to 1 volt. 1.00. There is some noise in the measurement. It's not stable. Anyway, let's go to 2 volts, 3 volts. Again, Marconi has changed the scale. 4 volts, 5 volts, pretty good. 7 volts RMS. I think it cannot go higher than this. 7 volts at 50 hertz. All right, so yeah, let's change now. Let's move up in frequency. Let's go to, because Marconi can go up to 1 kilohertz. So let's go straight to 1 kilohertz. 1 kilohertz. And we can see the frequency of 1 kilohertz. 7.012, 7.132. And now it's more stable, the reading. So yeah, pretty good. Let's go back to an amplitude of 100 millivolts. And I can change this one to be more accurate. Yeah, pretty good. Now the next experiment is to increase the frequency and see when the reading it starts to go down. So we know that up to 1 kilohertz as per specification is reading well. So let's move on now in 100 hertz steps. So you can see the frequency as I increase it on the left multimeter. Let me just round this number up. Yeah, just 1 hertz. Okay, so 1 kilohertz, 0.1. We see it's starting to to read lower. 1.3, 1.4, 1.5, 6, 7. Let's see where we got the minus 3 dB, which for voltage should be when we reach 0.7. Yeah, there we go, almost there. Yeah, so we are at 2 kilohertz. So the bandwidth is it's very flat, very good until 1 kilohertz as per the specification, and then we have a minus 3 dB point at 2 kilohertz. So not bad. Now let's switch that off, and we check now some how we can put some DC components on top of it. So let's go back to I don't know, 500 hertz, something in the middle. There you go. And let's put some DC offset. So for that we go on in here, we go to here. Like we can read DC, AC and DC offsets, but I think here we cannot differentiate. I think we read the sum. So let's put an offset level of I don't know, 100 millivolt DC. So we've got 100 millivolt DC and 100 millivolt AC. And if we read both together, we have 142 millivolts on the Bryman, 143.4. So pretty close. Happy with that. Yeah, let's go to 1 kilohertz, and let's go 1 volt RMS. Let's go to here, change this range. 1 volt RMS with an offset of 1 volt DC. So we can see that we've got 1 volt RMS, and combination of both is 1.42, 1.43. The accuracy for AC plus DC in the Bryman, we are at 500 Hertz now, no, 1 kilohertz, sorry. So we are in this range, and in this range, 5 volts is 0.8 plus 40 digits. But nevertheless, the reading is very close to one another. So yeah, I'm happy that the Marconi is giving good results. Okay, let's switch that off, and let's go now check some resistances. For resistance, Marconi can measure up to 1 megaohm with 1 ohm resolution, below 1 kilo ohm, or 3 digits, and the accuracy is plus minus 5% of the reading, plus 1 ohm plus 1 digit, so it's not doing very good for low values. But the nevertheless, we tested. But the Bryman is much more accurate, up to 500 ohms. The accuracy is 0.07% plus 10 digits. If we are higher than the first 10% of the range, so the first 10% will be 50 ohm or less. So let's go close to 500 ohms with the trim pot, and let's compare the reading. And after that, we this is by the way, this is a 10K potentiometer. So yeah, let's have a look at let's go to something like 500 ohms. There about. I'm starting now with a very low value, which is this one here, which is a this is a 0.22 ohms. The second band looks like purple, but actually it's red. I don't know why it looks purple on the camera. Let me check under the lens. On the camera looks purple, but if I look at it, it's absolutely red. Anyway, never mind. What's interesting here is what is the Bryman reading? It's 0.21. I'm pretty sure that I cannot read this with the Marconi, because to read this low value, I'd zeroed the cable resistance, and I cannot do the same with the Marconi. Yeah, the minimum the Marconi will give back to me is 2 ohms, even if I short is 2 ohms. So yeah, never mind. Let's move up to something like 50 ohm. It should be these two, or this one. This should be 12 ohms. So let's move on into that. Only two ends. So I'm reading 14 ohms, which, if you consider that shorting out the cable, I read 2 ohms. So if you consider that, the resistance will be 12 ohms. If we take a look on the Bryman, yeah, 11.9291. So, and on the Bryman, the leads are already zeroed. Yeah, more or less. Yeah, I'm at 0 again. Okay. So if I measure now the resistance, yeah, 11.97. Okay. So it's reading good. MARCONI is reading good. Let's move up to something else. Something like these resistance are all less than 100 ohms. Let's move up to something. So these are 330 resistors. I'm reading 329.2. What is the MARCONI saying? 331, once again minus 2, 329. That's very good. Let's go up again. These are 2 kilo ohms resistors. I'm reading on the MARCONI 2.174. Let's go check on the Bryman. 2.1819 basically. If we take out one digit, like the MARCONI, 2.19 versus 2.174. What is the difference? The difference is 1.6%. That's good. Sorry, this is the difference over 2.19. So the difference is 0.7%. 0.73%. So that's good. And now let's go into the mega ohm range. Checking some 1 mega ohms resistors. I have this reading from the MARCONI, which is reaching the top of its measurements range. 992, 994, 995, between 992 and 995 is oscillating a little bit. Not sure why. Okay. Yeah, let's go on to Bryman. 994, 993. So yeah, again, what can I say? Very good, very accurate, the MARCONI. Also up to the top of its range. Yeah, the last thing I can check is to reach the bottom of the scale. If I hold the range and I go down to, let's say, I don't know, 100 kilo ohms. Let's check that. Let's find the one. Okay, so I went for this, which is 3 with 3 zeros, so 33K. And I'm reading 33K here. I don't have much resolution at this range, but it's saying 23. Sorry, 33. Here on the range, it should measure is saying 34. Let's see what's the verdict from Bryman. 34. So yeah, that's it. I conclude this video here. I'm pretty much happy with the multimeter, and I mean that it works, because obviously when you buy something which is secondhand, you never know the conditions, especially you know, such a complex instrument like this. There are many things that can go wrong. Anyway, yeah, that's all for now. I think I'll take some other checks with this instrument. Yeah, probably I'll make another video for that. Maybe for, you know, AF tests, measuring levels of audio signals inputs which you can send in this port, and yeah, you can measure frequency, the level, distortion. Yeah, I think I did another video, yeah, on the Synod. What else? Yeah, you can do a lot of stuff with this instrument. Anyway, that's all for now. Thank you for watching, and hope you enjoyed it.